Hi guys, so grade 12 data management, MDM for you. Little video here for U4, sorry, U2A1. We are looking at the topic of, let me scroll up here, uh, stats, one variable stats, and we're looking at data analysis with graphs. So the only thing I want to do here is just make sure you don't get hung up on some kind of strange stuff here. So there are a bunch of different ways to organize data. The first one is a frequency table. So real easy. You have some data based on months, and then you just make a tally chart here. And then after the tally, so you go through here, and every time you see January, you put a line here, a tally for January. So you go through September, you find September down below, and you put a line. And then the only thing you want to do at the end is add up the tally marks, the jot marks, and tell me the frequency with a number. So that's called the frequency table. Very simple stuff. You might use a stem and leaf plot. So this is a little strange. So a stem and leaf plot. So here we have a bunch of different pieces of data here. We're talking about rainfall and number of days on which rain fell in 36 consecutive intervals of 30 days. In other words, let's look at the number of days that rain fell in a month for 36 months. Okay, so that's the data here. And the one thing that we're looking at here is it's kind of like a looking at the data and putting it in little group intervals here. But it's a little strange, a little awkward actually. So there are no days less than 5. Okay, so what they've decided to do here is have the first group uh, data be between 5 and 10. So 5 to under 10. So that's important also, right? Because we have 5 to 10, 10 to 15. So if you have 5 to 10 and then 10 to 15, you just got to be careful on the wording here. 5 to under 10. So that's 5, 6, 7, 8, 9. Once you get to 10, it's over here. So it's in this group here from 10 to 15. So if you count on your fingers, go ahead. You got 10, 11, 12, 13, 14. That's 5 different possible uh, pieces of data that could fit in here. You could have 10 days, 11 days, all the way up to 14 days. Each of these has 5 different pieces of data. So for example, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 here, and then 15 all the way to 19, et cetera, et cetera. So just be careful with that because sometimes that can cause some confusion when you get something like 10, which one does it go into? So the strange thing is it's called the stem and leaf plot. So what they're doing here is they're saying the stems are going to be 0 and the leaves are going to represent the 1 digit, but you're going to have different leaf plots. So I'm not a big fan of this stuff. It's kind of confusing. So what this is saying is this. This is from 0, sorry, this is, so the stem is going to be the 10 digits, okay, the digit in the 10 column. So if we have from 5 to 10, that means that you're going to start with a 0 and go all the way from 5, 6, 7, 8, 9. So the 0 is the number in the 10 column, right? And when you have the number 5 or the number 6, 7, 8, 9, the digit in the 10 column is a 0. So kind of confusing. I think I'm making it worse trying to explain it. But so you go through here and you go, this is from, basically this is from 5 to 9. This is, so you have 2 different stems here. They both start with 1. So these are numbers that are in the tens column. Okay, so you have 10, 11, 12, 13, 14 in this group. And then this group here, they've said, let's make this the third group here from 15 to 19. Okay, so this is, and why is there a 1 here and a 1 here? Because this is from 10. So you see the 1 in the tens column here, the 1 in the tens column here. And then here you see a 1 in the 10 column. That goes with this here, this group here that goes from 15 to 19. So kind of confusing uh, and kind of annoying, to tell you the truth. These are back-to-back stem and leaf plots. So what they've done here is they have taken two separate pieces of information, French marks and English marks, and they've put them and they've compared them here, which isn't the worst thing I've ever seen. So these are marks in the 30s, marks in the 40s, marks in the 50s, 60s, 70s, 80s, and 90s for 2 different uh, chunks of data here. We got the French mark and we got the English mark, right? So it's not horrible. So basically, so what's this 6 and a 6 here? I should have showed you that earlier. That's a French mark that corresponds to 66. Okay, let's try this one. 61. 61. So somewhere there are 2 marks of 61 and they happen to be side by side in the French data. Okay, so over here when I have 52, I go to 5 and I add a 2 here to say, look, there's a mark of 52 that's available. Is there more data than just a tally chart? I guess there is, okay, because you have the actual marks, 52, 58, 56. Is it more confusing? Definitely. Um, it definitely is, especially the previous example. So I just want to introduce you to that information. In general, what do you get from here? It's not horrible. You look here, see, here's something here. English marks are in general higher. No French mark was over 90. Okay, so but you could have got that from a tally chart. Okay, the only thing that you get that's extra is the actual marks themselves. You have 81 as the only French mark in the 80s, and the marks in the 80s for English are 87, 89, etc. Okay, so kind of confusing here. Case tables, just organizing data based on a certain stat. So this was about the London Knights, and you see this with sports stats all the time. You want to organize here. Corey Perry had 130 points, and you click on here, and then it'll order them here. Kind of neat. All these guys here: Corey Hunter, Dylan, Corey Hunter, Corey Perry. You can look at some of these guys here. Rob Schrempf. A lot of these guys still in the London region, live in the London region. Most of them are nice guys, the ones that I've encountered. And here you go, penalty minutes. Oh, it's bad here, but you can organize that way also. Keep going, bar graphs and charts. Bar chart, so organizing data with a bar graph. I think you guys know what that's all about. Excel, Google Sheets. Back in the day, there was something called Lotus 123. They take your data and they can organize this stuff really easily for. I think even Microsoft Word does a decent job. You'll be doing a lot of this eventually, organizing of data. Let's keep going. Last thing here is we're going to use here a pictograph. So I believe at some point this was not a square. It was something fancy, but somehow it turned into a square. So it doesn't matter here. But this here is going to show that for when you're counting the number of people somewhere, each square or each icon or whatever it is going to represent 1,000 people. So just a bunch of these. You have what here? 6 of these. That means St. Thomas has 6,000 people who own an Apple computer. I guess that's the question here. Histogram. You want to look at histogram. It's similar to a bar graph with one slight difference. You can watch the slideshow if you want. It has to do with the data itself. When you have a bar graph, um, you'll have spaces between. Histograms themselves do not. So graphical display of information. Slideshow, let's take a quick look at this if it loads. Oh, it's loading. Okay, so you want to look here. Histograms. Here, a histogram is a vertical bar graph which contains continuous data. So the difference between this and, so you can keep watching this here, and here are the histograms. The difference between, if I can pause this, I don't even know, there we go. So if I can pause this, the difference between a bar graph and a histogram is the space between the bars here, okay, so, and the key is that the data itself is continuous. So when you look at a bar graph, what you have, and the example that's back there about the months at the bottom, not the best example, but if you have a bar graph, picture that your x-axis having things that have nothing to do with each other. So for example, let me show you what I'm talking about here. So this is actually that note. I try to put it on here, but let me just see if I can get to a blank page and show you something here. Give me a second. So if you're going to have something, and let's say I take some information and I have, what's your favorite ice cream? Vanilla, chocolate, or strawberry, okay? And I do some polling and I get some info and 3 people like this and 5, and we go up and you make it what's called a bar graph, okay? So, and then you can read it off here, whatever, okay? Whatever this is, okay? Really quick, it doesn't really matter. But the difference is between this and a histogram is when you have a histogram, you're going to have no spaces between the data. And I'll show you why that is in a second. This here is a bar graph, okay? This is a histogram. This data here, what's on the x-axis, what you're surveying or what you're asking, depending on the information. So you have things like chocolates and that sort of thing, where you might have data that is choices that have nothing to do with each other. Okay, so when you have vanilla and chocolate and strawberry, there are 3 distinct flavors of ice cream. Now, don't say Neapolitan because that's a different story. Okay, but they are distinct. So we keep their bars away from each other. Okay, here you're going to have things that are measured by continuous data. So you might have something like integrals here. So for example, if I'm measuring the speed it takes somebody to do something, okay, and I got a whole class here, and I measure this, and it takes, this is between 0 and 5 seconds, and this is 5 to 10 seconds, this is 10 to 15 seconds, this is 15 to 20 seconds. The reason we don't put a gap here is there's no real distinction. Okay, there's no jump from 0 seconds to 5 seconds, and then the next little bit, even though we have them in group intervals here, 5 and 10, and we've grouped the intervals instead of having them continuously, with what you'd have with a line graph. There's no actual jump between 5 and 10, okay, on this side or that side. So what I'm saying is this: when you measure the continuous data, you go from 0 to 5, and then right less than 5. So 0.4999999 seconds, or sorry, 4.9999 seconds is over here. What about 5.00001? Well, that's over there. Okay, we've decided where to cut this off. Okay, when you look at the vanilla, chocolate, and strawberry situation, they're distinct things. Okay, the vanilla, chocolate, strawberry, very different. Here, we've just decided where the intervals are going to be. Okay, and that happens usually when you have things like things that you measure as your independent variable, the one you have at the bottom here. So, for example, anything that has to do with distance, anything that's measured in meters. Okay, so distance, length, width, all that stuff, and usually anything that's measured in seconds or in time. Okay, so that's the difference, just a small difference between a histogram and a bar graph. But when you make one of them, make sure you know the difference between them. Okay, this is continuous data. This is not continuous data, and that's about it. Okay, take care.